Okay, today we are looking at Newton's third law. So, the third and final law. The law says for every action there is an equal but opposite reaction. So, we are going to be identifying the action and the reaction. The action and the reaction have to be equal in force but opposite in direction. And this is really important. You know, forces work in pairs. Forces don't work alone. They always work in pairs. So there's always an action force and a reaction force, or force pairs. So if we go to the previous slides, and we look at this man throwing the bowling ball. So we need to identify what is the action force, what is the reaction force. When we're doing this, here's a big hint. The two forces are always on the same object. So we can't say the action force is the ball going forward and the reaction force is the car going backwards. Those are not the same objects. Instead, we would say the man applies a forward force on the ball. So forward force on the ball, bowling ball I'm guessing, and the ball applies a force back on the man. Has to be the same two objects. So the man and the ball, not the car. There's not a force applied on the car by the ball. So I'm going to say that again. The man applies a forward force on the ball applies a backwards force back on the man. So I know I can check myself and I can say, okay, am I doing this right? By saying, am I talking about the same two objects? Yes. And is it opposite in direction? Yes. Let's try another one. All right, this one's tricky. This is one that would be commonly missed. If I asked this, a lot of times I would just get like, you apply a force on the soccer ball. Okay, but what is the reaction? Where's the pair? Where's the second force? So we can see that he is applying a force on the soccer ball, a forward force on the soccer ball. But that means that we need an opposite reaction. So if he applies, if this is the soccer ball, if he applies a forward force on the soccer ball, that means the soccer ball is also applying the same amount of force back on him. That's why you feel things. If you kick a soccer ball, do you feel the kick impact on your foot? Yes. If you kick a soccer ball lightly, it feels very light. It's not a big impact. If you kick a soccer ball with all your force, you will feel a larger impact. If you hit a table, hit it lightly, light impact. Smack that table, you're going to feel it on your hand because the table applies a force back on your hand. So in our minds, it's natural to only see the forward force on the soccer ball. But you know that forces work in pairs and there's always an equal and opposite reaction. So the soccer ball is applying force back on his foot. So this is the law. This is what you're going to copy at the top of your notebook page. And then on the next 3 slides, you'll do the same thing you've done for the past 2 days. You are going to write and draw what you see, well, for the past 2 notes days. Y'all know that this right here is a link. You can click on this title and it'll take you to the video. So if this video doesn't work for you, you have a title, you can click on it, it'll take you to the video. Make sure that you are labeling the action force and the reaction force for each one. When you do this, it needs to be the same two objects. So if the action, like going back to the soccer ball, if the action is on the soccer ball and the foot applies a force on the soccer ball, the reaction is the foot and the soccer ball. You can't just throw a new object in there. Same two objects, opposite direction. You got it.